Right, we need to solve for x in this case. So given the sine of x equals cosine 3x, and we proceed to write down the solution to the problem. And we begin as follows. So we have with us here the sine of x, which equals cosine 3x. And this means we have the sine of x equals the sine of 90 degrees minus 3x, right? Which means we have the sine of x, which is the same as the sine of 90 degrees minus 3x. And what is the meaning of these? Well, it means, therefore, obviously, we need to note that we're dealing with quadrant 1 here, because it's 90 minus. So now we need to proceed to find the general solution, which is 90 degrees minus 3x. We add to these 360 degrees by k in z, which means we have 4x equals 90 degrees plus 360 degrees by k in z. Dividing both left and right by 4 gives us x equals 22.5 degrees plus 90 degrees by k, where k is an element of the set of integers. Right, and we proceed to say that is the solution, or now we are going to focus on the second quadrant, which means we have the sine of x equals the cosine of 3x. And this is the sine of x equals exactly the sine of 90 degrees minus 3x, like so. And this is the sine of x equals the sine of 90 degrees minus 3x, an angle in the first quadrant, 90 degrees minus 3x. And this is the sine of x equals the sine of 180 degrees minus into 90 degrees minus 3x. And so what is the meaning of these? This is the sine of x equals the sine of 90 degrees minus x. 180 degrees minus 90 is the same as 90 degrees plus 3x, like so. And what is all this here? So this means x equals 90 degrees plus 3x plus 360 degrees by k, where k is an element of z. And this is minus 2x equals 90 degrees plus 360 degrees by k, where k is an element of z. Dividing both left and right by -2 gives us minus 45 degrees. Right, you can maintain this as plus. Dividing 360 by -2 can maintain it as plus because it's multiplied by integers which take plus or minus. So it's 180 degrees by k, where k is an element of z. And what is this? So this is exactly the same as 135 degrees plus 100. Okay, let me just clean this up here. So this is exactly the same as, right, 135, because if k is 1, we have 180 degrees minus 45, which is 135 degrees plus 180 degrees by k, where k is an element of the set of integers. Okay, so that gives us a possible solution as well. Right, so we have those, and in other words, hence X is 22.5 degrees plus 90 degrees by K, where K is an element of the set of integers, right, by K, where K is an element of the set of integers, or X equals 135 degrees plus 180 degrees by K, where K is an element of the set of integers. All right, so that is what we get. Right, so alternatively, we have another way of doing the problem. So another student can approach this problem in a slightly different fashion. So how different? So one would have to look at the fact that if you have the sine of x, which equals the cosine of 3x, we can start by writing the cosine of 3x and equate it to the sine of x. By symmetry, this is true. By symmetry of the equation of the equality sign, this is true. And so this means we have cosine 3x, which means that we have cosine of 90 degrees minus x. All right, so if this is true, that we have cosine 3x equals cosine of 90 degrees minus x. What do we do here? All right, what do we do here? This means that 3x, because the cosine function is an even function, so this becomes plus or minus 90 degrees minus x. Becomes 90 degrees minus x. So it becomes 90 degrees minus x. Right. Plus the period, multiples of the period of the cosine, which is at 360 degrees, and this is what we get. So what is this? So this means 3x is 90 degrees minus x plus 360 degrees by k, where k is an element of z. Or we have 3x. Right, or we have 3x, which is minus into 90 degrees minus x plus 360 degrees by k, where k is in z, which means we have 4x equals 90 degrees plus 360 degrees by k, k in z. Dividing both left and right by 4 gives us x equals 22.5 degrees plus 90 degrees by k, where k is an element of z. Okay, this is the case, or if you distribute here, it becomes with the minus, you have minus 90 degrees plus x plus 360 degrees by k, k in z, like so. Transposing the x to the other side gives us 2x equals minus 90 degrees plus 360 degrees by k, where k is an element of z. Divide both left and right at this point by 2, and we have x equals minus 45 degrees plus 180 degrees by k, where k is an element of z. Right, upon further examination, these can be written as 135 degrees plus 180 degrees by k, where k is an element of z. And these here becomes the solution to this problem. And so we have that this is the answer and that becomes the answer. So these become the solutions to this problem, and we have solved this in detail. Thanks everybody for joining us, and goodbye to you. Goodbye.